Hey guys, welcome back. Houston Math Prep here. In this video, we're going to be working example 2 of polynomial graphing, putting it all together. Once again, if you're just joining us on this video and you haven't watched our videos on end behavior, turning points, and roots with behavior, make sure you watch those first and come back here when you're ready. Okay, let's jump right in, collecting our information, starting with finding the degree of our polynomial m of x. When our polynomial is in factored form, we're going to start finding our degree by adding up all of the powers of our factors. So in this case, the power of my factor of x is 1, plus the power of my factor of x plus 1 is 1, and the power from my factor of x plus 5 is 3. So 1 plus 1 plus 3 is 5. So my overall degree is 5. For my lead coefficient, remember, all I'm really concerned about is whether it's positive or negative. So I've got a negative up front. In here, I would get a positive out of my x plus 1. And in here, with positive x being cubed, I would get a positive. So a negative times a positive times a positive, I'm going to get a negative lead coefficient. For end behavior, I put those two items together. With a negative lead coefficient, I know that that tells me at the right, I'm going to be pointing down. With opposite behavior, because of this odd degree, that means on the left, I'm going to be pointing up. So I have this up-down end behavior. Moving along to gathering my roots and their behavior. First thing I'm going to take is my factor of x and set that equal to 0 to get the root 0, 0. My multiplicity there is going to be my power, is in this case 1, and odd multiplicity gives me cross behavior. Moving to my next factor, x plus 1, if I set x plus 1 equal to 0, that would give me a root of negative 1, 0. Again, my power there is 1, so I've got multiplicity 1, and odd multiplicity tells me I have cross behavior. For my last factor, x plus 5, if I were to set that equal to 0, that would give me negative 5, 0 as my root. I have a multiplicity of 3 there. Odd multiplicity tells me I have cross behavior. All right, now that we've gathered all of our pertinent information, it's time to put that on the graph. I'm going to start by plotting each one of my roots. So I have 0, 0 as a root. I have negative 1, 0 as a root, and negative 5, 0 as a root. Once I have all of those roots or x-intercepts graphed, I'm going to go ahead and add the end behavior to the furthest left and furthest right of my roots. In this case, negative 5 is my furthest left, so I'm going to go ahead and exit that going up. And my furthest to the right is 0, so I'm going to go ahead and exit that one coming down. Now all I need to do is use each root's behavior. All of them in this case are cross to connect what's going on in between. So starting at negative 5, I have cross behavior and I have multiplicity 3. Now remember, with multiplicity 3, we're going to kind of get that more flattened out crossing in comparison to an m equals 1, which is going to be a more linear crossing. So at negative 5, I'm going to come through and sort of flatten out, but still cross through. And then in order to get back over here to negative 1, I'm going to have a turnaround. So I'm going to turn back around, coming through my root here at negative 1. I have an m equals 1 cross, so that's just going to be nice and linear, go right through. And once again, I need to get back over here to 0 to cross through again, so I'm going to have a little turning point. So there's a rough sketch of my graph for m of x just graphing each one of the roots, putting our end behavior on the far left and far right, and using each root's behavior to connect in the middle. That does it for this video. We'll catch you later.